Have you ever wondered what would happen if you dropped an ordinary egg from space? Let's launch into a mind-bending thought experiment and follow our brave little egg on a cosmic journey. We'll use real science, no mess, no rockets required, to imagine what happens when gravity, speed, and Earth's atmosphere all come into play. So, put on your imaginary space helmet. Our egg-cellant adventure is about to begin. Our journey starts 400 kilometers above Earth, where the International Space Station orbits, far above the clouds and air. Up here, there's almost no air, so nothing slows you down. The ISS and our egg are zipping around Earth at 17,500 miles per hour. In orbit, you're not floating still, you're falling around the planet, always missing the ground. If you let go of the egg, it won't fall to Earth. It'll just keep orbiting right beside you like a tiny satellite. To make our egg fall, we need to solve our first physics puzzle. We have to get rid of that sideways speed. Only then will gravity pull it down toward Earth. So how do we slow it down? Let's find out. To fall to Earth, our egg needs to lose its incredible sideways speed, a process called a deorbit burn. Imagine strapping a tiny rocket to the egg and firing it backward, slowing it down just enough for gravity to take over. Now, the egg's path changes from a stable orbit to a spiraling descent toward Earth. It accelerates downward, picking up speed as gravity pulls it in. The peaceful silence of space is about to end. The real drama begins as the egg approaches the atmosphere. What happens next is a fiery test of survival. Let's see if our egg can make it through. As the egg slams into the upper atmosphere at thousands of miles per hour, it faces a wall of air molecules. The air in front of the egg compresses and heats up, creating a superheated plasma, hotter than the surface of the sun. The fragile eggshell vaporizes instantly. The insides are destroyed in a flash. Our egg becomes a tiny meteor, burning up before it ever reaches the ground. Earth's atmosphere acts as a shield, incinerating most objects that try to enter from space. This is why shooting stars streak across the sky, their space debris burning up just like our egg. Surviving re-entry is the ultimate challenge. So, how do real spacecraft make it home? Let's protect our egg. We'll design a mini spacecraft. Mission Egg Possible. First, we need a retro rocket to slow down from orbital speed. Next, a heat shield to absorb and deflect the searing heat of re-entry. The capsule's shape matters. A blunt, rounded cone pushes hot air away, keeping the egg safe. A sharp nose would melt. Blunt is best for re-entry. Finally, parachutes are essential for a soft landing. A drogue chute stabilizes the capsule. Then main parachutes deploy to slow it down. With these systems, our egg has a fighting chance. This is the same engineering that brings astronauts safely home. Let's see the science behind these life-saving designs. Gravity pulls our egg capsule down, accelerating it toward Earth. As it enters the atmosphere, air resistance, drag, fights back, slowing the fall. The faster you go, the stronger the drag. Eventually, drag balances gravity, and the capsule stops accelerating. This is terminal velocity. Parachutes dramatically increase drag, slowing the capsule from hundreds of miles per hour to a gentle landing speed. Mastering gravity and air resistance is the secret to a safe descent. Engineers use these forces to turn a deadly plunge into a controlled landing. Now let's look closer at the heat shield's magic. The heat shield is our egg's hero, using a process called ablation. As the shield burns away, it absorbs and carries off heat, protecting the capsule inside. It's like sweating. Evaporation cools the surface. The vaporized material forms a buffer of gas, insulating the egg from the hottest plasma. By the end of re-entry, much of the shield is gone, but the egg is safe. This technology made moon missions possible. For our egg, a mini heat shield is the key to survival. After surviving re-entry, the capsule is still falling fast. A drogue chute deploys first, stabilizing the capsule. Then the main parachutes open, creating massive drag and slowing the descent. The violent fall becomes a gentle float. The capsule drifts down, landing softly in a grassy field. Our science team rushes in and finds the egg safe and sound. Mission Egg Possible is a success, but what have we learned from this journey? Our egg's adventure reveals the real challenges of space travel. Getting to space is only half the story. Coming home safely is just as hard. Earth's atmosphere is both a deadly barrier and a life-saving shield. Every detail, from heat shields to parachutes, must be perfect. Science is for everyone. Curiosity and imagination can take you on amazing journeys. Next time you look at the stars, remember our egg and the science behind its journey. Keep asking questions. That's how every great adventure begins. The universe is waiting for your next big